Okay, hello. So this short tutorial will guide you towards how to create a network analysis and also a Bayesian network analysis in JASP. So first of all, with JASP open, don't worry about this text. It's because the dataset I just opened. And here you will find the module network here and should appear like in this form. And if you click on there, you can have the classical network analysis and also Bayesian network analysis. Okay, so to do that, and then this is an example of how to do a network analysis from a frequentist perspective. These are items of the big five. They are just 5 items for the consciousness scale and also the neuroticism scale. This is the main estimator of the network that is called a big lasso. So this is the expected Bayesian information criteria with the graphical lasso operator. There are other alternatives, but I will not elaborate that here. The important thing is that then you will create a correlation matrix that has been partialized and regularized, and it is going to be called the weights matrix. Okay, so here is the plot of the network, as you can see. And I just made an adjustment to create some color for the networks here in graphical options, where you can create each group of what you want. For example, conscientiousness and neuroticism, and then you just select each variable for the category you want, and it will color it. You can create also which colors do you want, and also if you want a palette, you can create another one. For example, here is the palette for ggplot. And as you can see here, the colors are from there, and also you can create another palettes. Okay, so in addition to this, you can create your own. You can ask for centrality indices that are here: betweenness, closeness, strengths, and expected influence. That are several metrics to try to map which variables are more important in the network. So you can also plot that like this, and as you can see here, the C5, the fifth items of the conscientiousness scale, is maybe the most central item here, and also with the C4 and also N4. So N4 is here, C5 is here, C4 is here. So that's the typical network analysis that you can do, although it's a very complex technique, and I advise to use that in R and search for tutorials to do some power analysis and also for bootstrap techniques. Okay, so how we can do this Bayesian? So you can go to the Bayesian network analysis that is here, and then we will put the same variables here, and we will ask for a network plot and also the edge evidence plot. This is the edge evidence plot, as you can see here in the presentation. Red line is evidence for the absence of an effect, so it's a bias factor that is between 0 and 1. Blue is the presence of an effect, so it's beyond, for example, bias factor of 10. And gray is inconclusive evidence. Okay, so you can even create simpler networks. For example, absence of evidence out, and also evidence for exclusion. So this is the network, the evidence network, just only for including those variables, but also we can create only for exclusion. As you can see here, these are all of the connections that have evidence to be excluded, that because they are probably 0. And also you can create only for absence of evidence, as you can see here, and this is the gray zone of the network, where do you not have evidence of if it's true or not. Okay, so now we can also ask for the network plot, that is this one. And then we can ask for the centrality plot that has the same metrics: closeness, betweenness, strength, and expected influence, but then with credible intervals for all of them, so the interpretation can be richer to see how many overlap and not or not. And also we have the posterior structure probability. And okay, so moving on, we can set the MCNC, for example, 5,000 burn-in operation and 10,000 samples, a seed also for replicability. You can have also properties of the prior, like prior edge inclusion, the initial configuration of this, and you can see it full or empty, and also the degrees of freedom of the Wishart prior. Okay, Uh, and also, this is the graphical options that are basically the same as in the standard network analysis, where you can use the disposition, colors, sizes, etc. And also the network selection, you can create this one of a posterior structure probability plot, and also posterior structure probability for this. And this is kind of a way of seeing how much complex of a network can be. Okay, so this is for network analysis from a Bayesian way. You can also compare things, as you can see here. We have divided the sample by gender, and we can see that the network is kind of different in some ways. For example, some edges are weaker or some edges are stronger between groups. Centrality also can be mapped to see if there are differences. There are not much differences actually. The split of this group is, the main outcome is that it is easy actually, and they are comparable. However, remember that this is basically a visual inspection and comparison of that, because there are specific tests to do that. For example, like the network comparison test, and also the joint graphical lasso, and all of other things. Okay, if we do that from a Bayesian point of view, we can create basically the same for the network plots, and also for the edge evidence plots, and also for everything that we have. Here is the centrality plot, but with credible intervals for both groups. As you can see here, they overlap almost in every occasion, except from this, for example. And also we have the posterior probability structure plots and the complexity plots. So this is like a quick way to make a Bayesian network analysis, and I think you can find it useful to make some quick analysis to then, for example, get into R and make it a more thorough analysis with Bayesian Gaussian graphical models.